Hi everyone. Hello. So welcome back to a very fresh session of DNA learning. This is me Shivani here and I'll be handling chemistry for you guys and I'm also handling chemistry for the class 12 students. So today we're gonna take the chapter 1 of class 11, some basic concepts of chemistry before beginning with the class or beginning with the chapter. Let me ask you, uh, how was your 10th standard? Yeah, many might have left the previous school and joined a new school for for some reasons, right? Or maybe the course which you wish to opt may not be there in your previous school, right? Or some of your friends might be leaving the previous school and joining some other school, some new school, and you also wanted to be with them, you wanted to stay with them, and so for the sake of that, you have left your previous school and joined new school. So whatever. I hope all of you miss your previous school. Some might not miss, and some might have got the fresh vibe of new school, right? Anyways, whatever. You have opted science, either biomax or computer science, whatever it is. I think you have opted science because you wish to opt it, not just for the sake of somebody else. Your parents or your relatives or your friends opted the same course, or your neighbors have suggested to take science because they've told you science has got large number of opportunities and friend. So I truly believe that you haven't opted this particular course just for the sake of the opinions given by some other people around you, but because you truly love this course. Okay, before beginning with the lesson, let me tell you a story, which is actually not a story but a real life experience from my life. It is actually a story from my own life. When I was in standard 11, I've opted by max for sure, and I've scored full marks in plus one, and the overall marks, the total marks of plus one and plus two, was 1,200, and I believe the total marks of plus one was 520. So I scored 520 by 520 in plus one. And yeah, for sure, a student like that, when coming to plus two, will have a tendency, a greater tendency to score full marks in plus two too, because she has already scored her full marks in plus one. So yeah, everyone's eyes, yeah, they were on looking me like whether I'll score full or not, where all those things. Yeah. So I was so tensed. I thought like it was like a huge burden was on me because as I've already scored full marks in plus one, it was like a duty or responsibility of mine to score full in plus two. Anyways, whatever. Even I had a stronger, deeper wish to score full in plus two too, and to score 1,200 by 1,200. And yes, of course, I reached plus two, and plus two exams got over. When the results came, I scored 99.5% in my plus two or in my higher secondary, and the 0.5% of my marks were gone because of chemistry. Yes, yes, the subject which I'm taking for you, which I'm handling for you itself. Chemistry. Chemistry. Those days, yeah, I really hated this subject, this chemistry, but I think I particularly hated this organic chemistry because I lost the 5 marks in organic chemistry. I strongly remember, like, I have a clear cut idea of which question I got wrong. A question of SN1, SN2 mechanism. Yeah, I really remember the question, the marks which I've gone due to that. So, what I'm going to tell you is that, or what I'm thinking, planning to tell you is that my 1,200 dream actually was not a success. It was partially a failure or partially a success because I scored 99.5% in my higher secondary and I lost zero point 0.5 due to chemistry, due to organic chemistry. I really hated this organic chemistry. So, what I wanted to tell you is that you should never approach a subject just for the sake of uh, scoring marks. You should never approach a subject just for the sake of scoring marks. Instead, you should have a passion for the subject. You should have a strong love for the subject. You should have an interest in knowing the subject closer and closer. If you have all those things, you'll definitely score full marks. So just don't approach it for the sake of scoring marks. In those days, I really studied organic chemistry just for scoring marks. I didn't understand. First of all, I didn't understand what the concepts meant, the organic chemistries and when I sent to mechanism. All those things are like, I never got any idea of those things. And just for the sake of scoring marks, I approached organic chemistry. And from there, I understood you shouldn't approach a subject just for scoring marks, but instead, you should approach it for understanding it in deep. Okay, then gradually you'll score marks, obviously. Okay, so we're going to start a new chapter, or we could say a new chapter of your life, because plus one and plus two, this is a this is a very important stage of your life, a crucial stage of your life. And from here, you'll be turning to different points. You'll be separated from your friends, your family, uh, because you're in search of your future. Okay, some might leave the hometown, some might leave uh, the state itself, or some might leave the country itself. Okay, in search of their dreams, in search of their passion. So, whatever, you must set a goal and then you must work for it. Okay? Let's start with the first chapter, some basic concepts of chemistry. In this chapter, as the title suggests, we are going to deal with the very basic concepts of chemistry. Okay, the very basic concepts of chemistry. So, before beginning with, let me tell you, my session will be going forward in the form of question answer type, so that you don't have to go in search of questions and answers for it. Fine. What is matter? What is a matter? You've heard about matter in your previous classes, I guess. Matter is anything that has mass and occupies a space. Is this pen? Okay, the pen is it a matter? Obviously, yes, no doubt. This has a mass of its own. This occupies a space. When I place it on my hands, it occupies a space and it has a mass too. Okay, I have a calculator here. Is it a matter? Yes, it has a mass of its own and it occupies a space. It occupies a space. It has a mass and it has volume of its own. So, whatever the things around us, if it occupies a space, if it has a mass of its own, then it is a matter. And we have some examples provided here: pen, pencil, book, etc. Clear? And what are the three states of matter? You're very familiar with the three states of matter: solid, liquid, gas. Solid, liquid, gas. So we need to know the properties of the three states of matter too. And what are the three states of matter? Solid, liquid, gas. When coming to solid, tell me the properties of solid with respect to its mass and the space occupied. Volume. Okay? Solid means it's actually a rigid body, right? It has got a rigid body. It has got a rigid surface. And what about its volume? Is it constant? Is it constant? Yes. Solid has got constant volume and constant mass. Okay, solid has got constant mass and constant space. Okay, coming to liquid. What are your comments about liquid? The shape of the liquid and the volume of the liquid. Shape. If I take a glass like this, in this glass, I have 500, okay, in this glass, I have 500 ml of water, okay, water, and I transfer it to a pot like this. Transfer the same into this, okay, same into this. What are the changes happening to this liquid or the water? Shape remains same or different? Obviously, shape remains same. No, shape is different. When I change it from glass to a pot, shape differs. And what about the volume or the space occupied by liquid? It's same, right? Same. Okay, what about the gas? From when we are talking about the gas, shape and volume. Neither definite shape, yes. Yeah, no definite volume, right? It occupies. I have a small box which has got this box is full of gas. Okay, consider this box is full of gas, and I'm just opening this box, and the gas is spread all over this room. Okay, all over this room. What about the volume of the gas? Volume of the gas is different. What about the shape? It is also different. So neither definite shape nor definite volume. Hope the properties are clear. And here we are talking about the conversions between solid, liquid, and gas. When consider the case of an ice from a freezer, you take an ice from the freezer, you just bring it to the room temperature. From a freezer, you take an ice and bring it to the room temperature, it melts. Because of what? Heat. And you heat it again, you further heat it. Okay, when I take an ice from the freezer due to the room temperature or the rising temperature, it becomes water. And when I heat it again, it becomes gas or vapor. When the vapor is condensed, it's cooled, it becomes liquid again. And when the liquid is freezed, okay, when I cool it, it becomes solid. Clear? So just keep this conversion in your mind. When solid is heated, it becomes liquid, and when liquid is heated, it becomes gas. The same when it cools. Okay, the same procedure, vice versa. When gas is cooled, it becomes liquid. Gas means when vapor, water vapor. When it is cooled, it becomes liquid. And when it is further cooled, it becomes solid. That is, when I turn a water, when I keep it in the freezer, what is actually happening? Cooling is happening, right? So it becomes ice. That means it turns into solid state. So just keep this in mind. Solid, when heated, it becomes liquid. Liquid, when further heated, it becomes vapor or gas. Gas, when cooled, it becomes liquid. And when it is cooled again, liquid is cooled again, it becomes solid. Now we are going to the classification of matter. What is matter? Matter is anything that has mass and occupies a space. So how can the matter be classified? Matter can be classified into pure substances and mixtures. Pure substances and mixtures. As the name suggests, pure substances are very, very, very pure. One simple technique to understand pure substance is that pure substance has got elements and compounds. Both the elements and compounds are from periodic table. From periodic table. Okay, you'll be given a set of substances and you'll be asked to pick the mixture from it, the homogeneous mixture, heterogeneous mixture, pure substance, the compound from it. Okay, so whenever there is a substance from periodic table, no doubt it will be pure substance. Then how to distinguish between elements and compounds? Elements and compounds. Let me tell you. Element means we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. All those are elements. When two atoms combine, HH, it becomes H2. OO, it becomes O2. All these are elements. Okay, we know that hydrogen, helium, lithium, beryllium all are from periodic table. And what are compounds? When two different elements combine. For example, carbon and oxygen, it forms CO2. And hydrogen and water combines. Oxygen combines, it becomes water. Or hydrogen peroxide, ammonia, all those are compounds. So elements and compounds will surely be from periodic table, and the only difference between elements and compounds is that elements have same type of atoms, H, C, O, O, forming O2, H2, etc. But in the case of compounds, you have different type of atoms or different type of elements forming. Nitrogen and hydrogen combines ammonia, gives ammonia. Carbon and oxygen combines to form carbon dioxide. Likewise, it combines in different ratio to form compounds. Now, in the case of mixtures, as the word suggests, mixture, it's a mixing of two or more components. The mixing can be done in two ways: homogeneously and heterogeneously. Okay, homogeneously and heterogeneously. Mixtures means it's a mix of different substances. The mix of different substances can be made in two ways: homogeneously and heterogeneously, and they are called as homogeneous mixtures and heterogeneous mixtures. Clear? Homogeneous mixtures means the components combined to form solution, or the components combined to form a mixture, have uniform property throughout. Uniform property throughout. You can't distinguish between the components combined to form a mixture. You can't distinguish between them. For example, when I take a salt solution, what is salt solution? Salt solution means I take 500 ml of water in a glass. Okay, 500 ml of water in a glass, and I dissolve some amount of salt in it. That is salt solution. Okay, after some time, are you able to see salt particles down settle down? Are you able to see the sediments of salt under? Are you able to see the salt settling down? No, salt will be completely dissolved in water. So that is a homogeneous mixture. You won't be able to distinguish between salt and water once it dissolves. And when I take a spoon and taste few drops of salt solution from the top surface, it tastes same as few drops of salt solution when I take it from the lower surface. It tastes same. That means it has same property. So homogeneous mixture means when two components combine to form a mixture. When I mix two components to form a mixture, it has uniform properties throughout. I won't be able to distinguish between the components which have mixed. But in the case of heterogeneous mixture, I will be able to distinguish between the substances because they won't be dissolved. They won't be completely dissolved. Okay, hence they are called hetero, different. Okay, they'll stand different even if they are combined. So let's look at some examples given here. Element. In the case of element, all the elements in periodic table form the element category of pure substance. In the compound, I've already said compound is also from the periodic table. Okay, CO2, H2O means different type of atoms, different type of elements combined to form compounds. Coming to homogeneous mixture, air is a very good example of homogeneous mixture. There are plenty of elements in the air. Oxygen, right? Carbon dioxide. Are we able to distinguish between oxygen and carbon dioxide by seeing or by any means? But they are combined in a fixed ratio, right? They are combined in a fixed ratio and they dissolve to form air. We're not able to distinguish, and the properties remain uniform all over. Salt or sugar solution. As I already said, if I take some water and dissolve some salt or sugar in it, it dissolves in it. It won't leave sediments. It won't leave particles. It won't settle down. But in the case of heterogeneous mixture, muddy water. Take some sand or soil, put it in water. Some particles will remain at the top. Some particles will remain at the bottom. Because what? They're not heterogeneous. They are not homogeneously distributed. The properties are different. They don't dissolve. I can differentiate between the components. I can separate the components easily, right? I can separate the components which are combined to form the mixture easily. Hope it's clear. Now we are moving on to the laws of chemical combination. In this chapter, we are going to learn 5 laws of chemical combination, which are law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac's law of gaseous volume, and finally Avogadro's law. Shall we start with 5 laws? And I'll tell you what all to be studied in this 5 laws very clearly. Just go for that not any other informations regarding that. Okay. First of all, law of conservation of mass. Mass can neither be created nor be destroyed. Okay, mass can neither be created nor be destroyed. If I have a mass, it can neither be created and it can neither be destroyed. So we need to illustrate this law by an example. Let's see. We have C plus O2 CO2. What is the mass of carbon? What is the mass of carbon? 12, right? 12 grams. And what is the mass of O2? O2. 16 into 2, 32. Yes, 32 grams. And what is the mass of carbon dioxide? Carbon dioxide has one carbon atom and two atoms of oxygen. So definitely 12 plus 32 gives 44. 44 grams. So you can see here, when I combine a carbon with two hydrogen atoms, oxygen atoms, I have CO2. One carbon, here also one carbon. Here two oxygen atoms, two oxygen atoms. Okay. So carbon is neither be created nor be destroyed. Oxygen also neither being created nor be destroyed. Here carbon dioxide is neither being created nor be destroyed. Same mass of the reactants remain same as the mass of the products. So mass is neither created nor be destroyed. Next is law of definite proportion. Law of definite proportion. It was proposed by Joseph Proust. Joseph Proust. So you need to remember the name of the scientist, the name of the law, what the law says, and an example. Joseph Proust. So how can you remember this name? DJ. D for definite, J for Joseph. DJ. Definite proportion. Law of definite proportion proposed by DJ. Not DJ, I mean the definite proportion rule by Joseph Proust. Or else you can remember by DP. The DP of WhatsApp, the DP of Instagram, the DP of Facebook, display profile. Okay, whatever. That's not the display profile, not here. This is for D for definite and P for Proust. So either DJ, that is definite proportion by Joseph Proust, or DP, definite proportion by Joseph Proust, P for Proust. So what the law says. The same compound always contains same elements combined in fixed ratio by mass. When I take a compound, it has got two elements or more than two elements. It will be combined in the same ratio to form a product. For example, if I need NH3, okay, how can I combine? Or else we'll take another example. CO2 itself. CO2 is here. Carbon plus oxygen. CO2. This is a very simple example. That's why I took carbon dioxide. Okay, carbon 12, 32. We know that this is 44. Doesn't matter. 12 is to 32. Just take the ratio of the reactants. 12 is to 32. When I make it short, dividing by 6, divided by 2, here 6 and here 16. Again divide by 2, we get 3 is to 8. Okay, 3 is to 8. Yeah, here 3 is to 8. Okay. So whenever carbon and oxygen combine in the ratio 3 is to 8, I get carbon dioxide. This is what the law means. Hope it's clear. Whenever carbon and oxygen combine in the ratio 3 is to 8, I get carbon dioxide. So just come back to the law. The same compound, that is CO2. For example, okay, CO2 always contains same element, always contains carbon and oxygen combined in fixed ratio by mass, that is 3 is to 8. Another example, H2O. 2 is to 16, right? Masses of hydrogen and oxygen. That is 1 is to 8. When hydrogen and oxygen combines in 1 is to 8 ratio, we get water. Clear? Law of multiple proportion. We have studied law of definite proportion. Now it comes law of multiple proportion. If two elements combine to form more than one compound. The fixed mass of one of the elements combined with varying mass of other element will be in simple whole number ratio. I'll explain the law by illustrating an example. Consider the case of H2O and H2O2. When H2O is combined, okay, we get 2 plus 16, that is 18, right? 2 and 16, H2O. H2O2, hydrogen peroxide. 2 plus O2 means 32, right? O2 means 32. H2 means 2. That is 34 grams. 18 grams, 34 grams. So as per the law, there is a simple whole number ratio between the components or between the elements. One element should be fixed and the other element, the mass should be variating. Different. The mass should be different. Here the fixed mass the fixed masses of hydrogen 2 and 2. Which mass is varying? Which mass is varying? Of oxygen 16 and 32, right? 16 is to 32 gives 1 is to 2. So that's the law proposed by John Dalton. Law of multiple proportion. If two elements here in this case hydrogen and oxygen combine to form more than two products, okay, that is H2O and H2O2. The fixed mass of one of the element here in this case hydrogen combined with the varying mass of other element. In this case oxygen is varying. In one case it is 16 and in the other case it's 32. Bears a whole number ratio. Clear? 16 is to 32. 16 is to 32 because oxygen mass is varying. Gay-Lussac's law of gaseous volume. In this law, Gay-Lussac, as per the title itself, we can easily connect the name of the scientist, Gay-Lussac's law of gaseous volume. The law is proposed by Gay-Lussac. When gases combine to form products, a simple ratio exists between the volumes of reactants and volumes of the products at constant temperature and pressure. Okay, at constant temperature and pressure, when gases combine to form gaseous products, there is a simple whole number ratio between the reactants and the products. When? What is the condition? When the temperature and pressure remains constant. Let me illustrate that. Consider the STP, standard temperature and pressure condition. In standard temperature and pressure condition, temperature will be 273 Kelvin. Pressure will be 1 atm. Standard temperature, pressure. Number of moles will be 1 mole. Okay, for 1 mole, the volume will be 22.4 liters. You might have studied about this in the previous class. From where did I got these values? What does the Boyle's law say? Pressure, volume inversely proportional to pressure. Charles' law, volume directly proportional to temperature. Avogadro's law, volume directly proportional to number of moles. Right? So from here, we can say that volume depends on pressure, temperature, number of moles. Yeah, pressure, temperature, number of moles. At 273 Kelvin temperature, 1 atm pressure, and when the number of moles is 1 mole, the volume will be 22.4 liters. So consider the case of H2 plus Cl2 gives 2HCl. H2 plus Cl2 gives 2HCl. 1 mole of hydrogen is used here. 1 mole of chlorine is used here, and it forms 2 moles of hydrochloric acid, right? So 1 mole means 22.4 liters. 1 mole chlorine means 22.4 liters. 2 moles of hydrochloric acid means 44.8 liters. Take the simplest whole number ratio, and 1 is to 1 is to 2. Right? 1 is to 1 is to 2. That is written here. When gaseous reactants combine to form products at standard temperature and constant temperature and pressure, there exists a whole number ratio between the products and the reactants. So it shouldn't be this. I'm not forcing to take standard temperature and pressure condition. You can take any temperature and pressure, but it should be constant. It should be constant. And just I just took the case of STP here because it is really easy to convey the idea to you. Okay, so let me tell you once again that at constant temperature and pressure, when you keep the temperature and pressure constant, and when you combine two gases, it forms a product, right? At constant temperature and pressure, the ratio between the x is the ratio, simple whole number ratio between the gases, gaseous reactants, and gaseous products. Finally, Avogadro's law, the last law, law of conservation of mass, law of definite proportion, law of multiple proportion, and Gay-Lussac's law was the fourth law, and finally Avogadro's law. Avogadro's law is nothing. In the previous case, we have took standard temperature pressure condition with number of mole 1, right? Here, when at the STP, temperature is 273 Kelvin. At STP, standard temperature and pressure condition, P is 180, and let the volume be 22.4 liters. Then what will be the number of moles? 1. Right. So this is the case that the law is saying about. Equal volumes of all gases at same temperature and pressure contain equal number of molecules. At same temperature, at same pressure, when the volume is same, 22.4, when the volume is 22.4, the number of moles or the number of molecules will be 1 or 6.022 into 10 raised to 23. Okay, I'll tell you one more example. Consider CO2 and NH3. Each has got 1 mole, right? At 273 Kelvin, at 1 atm pressure, I'm keeping the temperature and pressure constant, okay? It will surely have 22.4 liters. Then what will be the number of molecules? 6.022 into 10 raised to 23. 6.022 into 10 raised to 23. What is this? 6.022 into 10 raised to 23. Avogadro number. Avogadro number depicted by Na. Avogadro number. Clear? Okay, so for the time being, we are winding up this session. In the next class, I'll be doing some problems of the topics taken today. Okay, then we'll move on to the we'll further take the classes of other topics too. Clear? Hope you enjoy today's class, and in further classes, I assure you that you'll have an easy going with the further topics too. So before the next class begins, you must learn the topics which I've taken today, and be ready to attempt the questions I have in store for you all. Okay, all the questions will be based on the topics which I've taken today. Fine. So you need to learn the topics which I've taken today. What all did we learn today? What all did we learn? We have learned what a matter is, and what are the properties of matter, what are the 3 different states of matter, and how a matter can be classified. That is pure substances and mixtures. A mixture can further be divided into homogeneous mixture and heterogeneous mixture. Pure substance can further be divided into element and compound. Then we learned the laws of chemical combination, that is law of conservation of mass, definite proportion, multiple proportion, Gay-Lussac's law, and Avogadro's law. Just remember that you need to know the name of the law, the scientist, you need to know how to state the law and to illustrate the law. A single example is required. Fine? Fine. Ready? Okay, then we'll meet in another session. Till then, bye.